All right, so, like picking up a pencil.
Yeah.
It seems so simple. We hardly even think about it. But that seemingly effortless action is like a total head-scratcher for robots.
It is.
So we're going to explore the world of robot hands today.
Cool.
And why something we do without a second thought is so challenging for machines.
Okay.
Our sources today are a mix of academic papers, robotics articles, and even some patent filings.
Nice.
Which always give a peek into the future.
Yeah.
So the goal today is to unpack why giving robots the dexterity of a toddler is turning out to be way more complex than rocket science.
It's true. Robots are mastering things like navigating streets, playing complex games, even composing music.
Right.
But when it comes to the physical world, like picking up a coffee mug without crushing it, or assembling furniture, they're still lagging behind.
I was reading about this thing called the doorknob problem. It's like even super advanced robots can get stumped by a simple doorknob.
Wow.
It really makes you realize how much we take our hands for granted.
Exactly. And this gets to the heart of Moravet's paradox.
Okay.
Things that are easy for us are incredibly difficult for robots and vice versa.
Yeah.
It's not just about difficulty, though. It's about what those difficulties reveal about how our brains work.
So help me understand this better.
Sure.
Like, why is what we do unconsciously so hard to replicate?
Well, Moravec pointed out that our unconscious abilities, like grasping walking, even perceiving the world around us, are the result of millions of years of evolution.
Wow.
And those solutions are deeply embedded in our nervous systems, making them hard to break down into steps a computer can understand.
So it's like we've got this incredible software honed over eons, but no access to the source code.
Exactly. And that makes programming those abilities into a robot incredibly challenging.
Yeah. So we've got computers beating chess grandmasters.
Right.
But they struggled to open a door.
Yeah.
Okay, that's mind-blowing. So if simply copying the human hand is so complex, what are some of the other design approaches out there? I've heard about these like grippers.
Oh, okay.
But they seem pretty limited.
You're right.
Yeah.
Grippers are great for controlled environments, like factories where objects are always in the same place.
Right.
But in the real world, with its messy variability, they fall short.
Okay.
Think about a kitchen.
Yeah.
Different shapes, sizes, materials.
Right.
A robot chef would need a level of versatility that grippers just don't have.
That makes sense.
Right.
So what are the researchers cooking up?
Well,
what are some of the promising alternatives?
One exciting area is soft robotics, which uses flexible materials like silicone and rubber to create hands that can mold around objects.
Interesting.
Think about how an octopus wraps its tentacles around things.
So instead of trying to build a hand with all the bones and tendons and stuff, they're going for something more adaptable.
Exactly. We're seeing some cool designs like the three-fingered hand from iRobot.
Okay.
The Roomba, folks.
Yeah.
It's way more flexible than a gripper and can handle a lot more objects.
Right.
Then there are these silicone hands that use air pressure to curl their fingers.
Oh, wow.
Kind of like a balloon inflating and deflating.
That's fascinating.
Yeah.
But how do these soft hands sense the objects they're interacting with? Like, our fingertips are incredibly sensitive.
Yeah.
How are they replicating that?
That's the next big hurdle.
Yeah.
Sensing is key for manipulation.
Right.
Our fingertips have thousands of tiny receptors that give us a ton of information about pressure, texture, temperature. Trying to build that level of sensitivity into a robot is a huge challenge.
And it's not just building the sensors, right? It's making sense of all that data.
Yeah.
It's like drinking from a fire hose of information.
Precisely, even if we could build sensors.
Yeah.
As sensitive as human skin.
Right.
We need powerful algorithms to process that data in real time.
Okay.
Which brings us to the brains behind these robot hands.
All right, let's talk about those brains.
Okay.
Because I'm guessing programming every possible scenario for how to pick something up would be a nightmare, right?
Yeah, it would be a nightmare.
Especially in the real world.
Right.
Where things are unpredictable.
Yeah, you're getting it.
Yeah.
Traditional programming where you write specific instructions for every movement is just too rigid for the real world. Imagine trying to pre-program a robot to pick up every single object in your house.
It would be like trying to write a manual for life itself, right?
Exactly.
Yeah.
And that's why researchers are turning to machine learning, letting the robots learn from experience.
I've heard a lot about machine learning, and I'm curious how it's being applied to this specific problem of robotic manipulation.
It's about letting the robots figure things out.
Okay.
Not dictating every move.
Right.
We can feed them data, examples of successful and unsuccessful grasps.
Yeah.
And they use that to get better.
So it's kind of like how we learn to say chop vegetables.
Yeah.
We don't start out perfect.
Right.
We get better through trial and error.
Uh-huh.
Adjusting our grip and the angle of the knife.
That's a great analogy.
Cool.
But even with machine learning, there's a catch.
I'm guessing it needs a ton of data and time to learn.
Yeah.
Like a robot can't spend weeks just figuring out how to pick up a coffee cup.
You're right. Current machine learning algorithms need massive amounts of data and training time.
Okay.
The real challenge is figuring out how to make robots learn from just a few examples, just like humans do. It really makes you think.
It does. If training a robot to pick up a coffee cup is that hard, it makes you realize how complex something as basic as grabbing is.
It all comes back to that Moravet's paradox we talked about.
Right.
The things we do without thinking are the hardest to program. It really highlights how much of our intelligence is tied to our physical interactions with the world.
I never thought about it that way.
Right.
We tend to think of intelligence as abstract thought, logic, reasoning.
Yeah.
But maybe those like higher functions are actually built on a foundation of incredible sensory and motor skills.
Exactly. Our brains have evolved to master these physical interactions.
Wow.
And those solutions are deeply embedded in our nervous systems.
So it's not just about building a robot hand.
Right.
It's about replicating millions of years of evolution.
That's a great way to put it.
Yeah.
And it's why traditional programming just doesn't cut it.
Right?
You can't simply code every possible scenario.
It's like we're trying to reverse engineer a masterpiece without the blueprint.
Yeah.
And that's where machine learning comes in.
Okay.
Instead of trying to dictate every move, we're letting robots learn from experience just like humans do.
But how do we get them to learn quickly and efficiently?
Yeah.
We can't have robots fumbling around for hours just to figure out how to pick up a fork.
Right.
They need to generalize from just a few examples like we do.
That's the million-dollar question in robotics right now.
Wow.
We need algorithms that can learn from limited data and adapt to new situations.
So we need robots that can learn more, like humans do.
Exactly. Humans are incredibly good at transferring knowledge from one task to another. If you learn to chop carrots, you can probably figure out how to chop celery without starting from scratch.
Right. It's like we build upon our previous experience. We don't treat every new task as a completely new problem.
Right.
But how do you teach a robot to do that?
That's where things get really interesting. Researchers are exploring a type of machine learning
called reinforcement learning.
Okay.
Where robots learn through trial and error, receiving rewards for successful actions.
So kind of like training a dog.
Yeah.
Give them a treat when they do something right.
In a way, yes.
Okay.
But instead of treats, we use algorithms that reinforce the robot's actions.
Okay.
When they lead to a desired outcome. It's like teaching the robot to learn from its mistakes.
That's amazing.
Yeah.
But it still sounds like a pretty slow process.
Yeah.
Especially when you think about all the different objects and environments a robot might encounter in the real world.
It is. That's why researchers are also looking at ways to combine reinforcement learning with other approaches. One idea is to use simulation environments to speed up the learning process.
Oh, like a virtual training ground?
Yeah.
Where the robot can practice thousands of grasps without breaking anything in the real world?
Exactly. These virtual environments can be used to generate synthetic data, which can then be used to train the robot's algorithms.
So we're training robots in the Matrix. Yeah, it's pretty wild.
It is pretty wild.
But what about the tactile part?
Yeah.
How do they learn to feel in a virtual environment?
That's a crucial piece of the puzzle.
Okay.
And it gets back to the challenge of sensing we talked about earlier. Researchers are developing sophisticated tactile sensors that can measure pressure, texture, even temperature.
So these sensors would give the robots the ability to feel objects.
Yeah.
Even in a virtual world.
They would.
I guess that would make the training a lot more realistic.
Exactly. And some researchers are even experimenting with haptic feedback systems that allow humans to feel what the robot is feeling.
Wow. That's next level.
It is.
So we're talking about a future where robots could learn to manipulate objects, with the same dexterity and sensitivity as humans.
That's the ultimate goal.
Wow.
And it's closer than you might think.
Really?
We're seeing remarkable progress in both the hardware and software aspects of robotic manipulation.
It's incredible to think about the possibilities.
It is.
But it also makes you wonder about the implications.
Yeah.
What happens when robots can interact with the world as seamlessly as we do?
That's the big question.
Yeah.
It's both exciting and a bit daunting.
It makes me think about all those sci-fi movies where robots take over the world.
Right.
But hopefully we can avoid that scenario.
I think it's important to have open and honest conversations about the ethical implications of advanced robotics. We need to make sure that these technologies are developed responsibly and used for good.
It's not just about the technology itself.
Right.
It's about how we choose to use it.
Exactly. We need to be thoughtful and deliberate in how we integrate these technologies into our lives.
Okay.
But I'm optimistic that we can create a future where robots are our partners, not our replacements.
That's reassuring to hear.
Yeah.
But let's get back to the technology itself for a moment. We've talked about the challenges and the potential.
Right.
But what about the current state of the art? What can robots actually do today?
We're seeing some really impressive advancements.
Okay.
In areas like warehouse automation, manufacturing, even surgery.
Wow.
Robots are being used to pick and pack orders, assemble complex products, and assist surgeons with delicate procedures.
So they're already making an impact in specific domains.
They are.
But what about the more general purpose robots?
Yeah.
The ones we might see in our homes or workplaces someday?
That's where things get a bit more challenging.
Okay.
While we've made great strides in research labs, it's still early days for truly versatile robots that can operate in unstructured environments.
What are some of the key hurdles we need to overcome to get there?
One of the biggest challenges is robustness.
Okay.
Robots need to be able to handle unexpected situations and recover from errors. They can't just freeze up or crash if something goes wrong.
All right, they need to be able to adapt and improvise, just like humans do.
Exactly, and that requires a level of sophistication in both their hardware and software that we're still working towards.
So it's not just about building better hands, it's about building better brains.
Precisely. We need to develop algorithms that can reason about the world, make decisions, and plan actions in complex dynamic environments.
And that brings us back to the importance of machine learning, right?
Absolutely. Machine learning is a key enabler for building robots that can learn and adapt. But we need to go beyond the current state of the art.
What are some of the cutting-edge developments in machine learning that are particularly relevant to robotics?
One exciting area is meta-learning, which is about teaching robots to learn how to learn.
That sounds kind of meta.
It is. Yeah. The idea is to train robots on a variety of tasks. So they can learn how to quickly adapt to new situations and generalize their knowledge.
So it's like giving them a toolkit of learning strategies that they can apply to different problems.
Exactly. It's a way of making robots more adaptable. And less reliant on massive amounts of data for every new task.
That sounds incredibly promising.
It is.
But what about the other side of the coin?
Right.
What about the potential risks of giving robots this level of dexterity and autonomy?
It's important to address those concerns.
Yeah.
As robots become more capable, we need to think carefully about their role in society and how we ensure they're used ethically and responsibly.
So it's not just a technological challenge, it's a societal one as well.
Absolutely. We need to have open and honest conversations about the potential impact of these technologies on our lives, our jobs, and our future.
It's a lot to consider.
It is.
But it's also incredibly exciting.
Yeah.
It feels like we're on the cusp of a new era in robotics, one where robots could truly become our partners in solving some of the world's most pressing problems.
I agree. And it all comes back to those seemingly simple actions like picking up a pencil.
It's amazing how much complexity is hidden in plain sight.
It is.
And it makes you appreciate the incredible power of our own brains.
It does indeed.
Well, we've covered a lot of ground in this deep dive.
We have.
We've talked about the challenges, the potential, and the ethical considerations of giving robots the dexterity of a human hand.
It's been a fascinating journey.
But before we wrap up,
Okay.
I want to leave our listeners with a final thought.
Yeah.
We've focused a lot on the challenges, but let's shift gears and talk about the possibilities.
Yeah.
What happens when we crack the code
Right.
of robotic manipulation?
Okay.
What could that future look like?
The potential is huge.
Wow.
Imagine robots that can work alongside humans
Uh-huh.
in all sorts of environments, not just in factories, but in our homes, hospitals, out in the field.
I can picture robots assisting surgeons with incredibly precise movements.
Right.
Or maybe even venturing into disaster zones
Yeah.
to help with search and rescue.
Mm-hmm.
What about everyday life?
Yeah.
Could robots finally tackle those household chores we all dread?
Exactly. Elder care is another area where robots could make a huge difference, helping people age in place with dignity and independence.
Right.
And yeah, those more mundane tasks like folding laundry or loading the dishwasher,
Right.
maybe robots can finally take those off our hands.
It's not just about replacing human labor, is it? It's about augmenting our capabilities.
Yeah.
Doing things we couldn't do before.
Right. Think about space exploration.
Go.
Robots with advanced manipulation skills could build structures on other planets,
Wow.
conduct complex experiments,
Yeah.
and explore environments that are too dangerous for humans.
That's incredible.
It is.
But it also makes you wonder about the potential downsides.
Yeah.
Job displacement is a big concern. And there are those who worry about robots becoming too autonomous, even posing a threat to humanity.
Those are valid concerns.
Yeah.
And it's crucial to have open and honest conversations about them. We need to ensure that these technologies are developed and used responsibly with careful consideration of the ethical implications.
So it's not just a technological challenge.
No.
It's a societal one.
Absolutely. The future of robotics isn't something that should be decided by engineers and scientists alone.
Right.
It's a conversation we all need to be part of.
We need to be thinking about the kind of future we want to create.
Yeah.
Not just the technology itself.
Exactly. And I'm optimistic that if we approach this thoughtfully, we can create a future where robots are our partners, not our replacements, working alongside us to solve some of the world's biggest challenges and improve our quality of life.
So from something as seemingly simple as picking up a pencil, we've uncovered a whole world. Of complexity, innovation, and possibility.
It's been a fascinating exploration, and it really underscores the remarkable capabilities of the human brain and the exciting future of robotics.
To our listeners.
Yeah.
Thank you for joining us on this deep dive into the world of robot hands.
It's been fun.
It's a field that's constantly evolving, so keep those questions coming and stay curious.
Absolutely.
Who knows what incredible advancements we'll see in the years to come.